Our worked example follows a delivery van and its company through every topic in mechanics and statistics as one continuous story. The van starts from rest and accelerates at 2 meters per second squared for 6 seconds. Using the formula, final velocity equals initial velocity plus acceleration times time, that is v equals u plus at, the final velocity works out to 12 meters per second. Using the formula, distance equals initial velocity times time plus 1/2 times acceleration times time squared, that is s equals ut plus 1/2 a t squared, the distance covered is 36 meters. As a check, using v squared equals u squared plus 2as, both sides give 144, so the answer is confirmed. The same journey drawn as a velocity time graph is a straight line rising from 0 to 12 meters per second over 6 seconds. The gradient of that line is 2 meters per second squared, which matches the acceleration. The area under that line is 36 meters, which matches the distance traveled. The van has a mass of 1,500 kilograms. Using Newton's second law, force equals mass times acceleration, the driving force needed is 3,000 newtons. As a check, rearranging for acceleration, 3,000 divided by 1,500 gives 2 meters per second squared again. The van is now parked on a slope of 10 degrees. Its weight is 14,700 newtons, acting straight down. Resolving down the slope gives a force of about 2,553 newtons. Resolving perpendicular to the slope gives a normal reaction of about 14,479 newtons. As a check, combining both components using Pythagoras returns the original weight of 14,700 newtons. The coefficient of friction between the tires and the road is 0.3. The maximum friction available is about 4,344 newtons. Since that maximum friction is bigger than the 2,553 newtons pulling the van down the slope, the van stays still. The van then drives 100 meters against a resistance of 800 newtons. Using the formula work done equals force times distance, the work done against resistance is 80,000 joules. If this takes 20 seconds, then using power equals work done divided by time, the power used is 4,000 watts. As a check, using power equals force times velocity, 800 newtons times 5 meters per second also gives 4,000 watts. The van, moving at 12 meters per second, has a momentum of 18,000 kilogram meters per second. It gently taps a stationary trolley of 100 kilograms and they move off together. Using conservation of momentum, total momentum before equals total momentum after, their combined speed is 11.25 meters per second. As a check, multiplying the combined mass by that speed returns 18,000 kilogram meters per second again. A small package now falls from the back of the van, 1.25 meters above the ground, while the van moves at 11.25 meters per second. The vertical fall takes about 0.505 seconds. In that same time, the package also travels about 5.68 meters horizontally. This is shown first as the 2D falling path, then with the same running caption updated to show the horizontal and vertical motions drawn separately. The package lands on a ramp of length 2 meters, resting on 2 supports, weighing 50 newtons and sitting 0.5 meters from the left support. Taking moments about the left support, the right support provides 12.5 newtons. Since the total upward force must balance the weight, the left support must then provide 37.5 newtons. As a check, taking moments about the right support instead returns the same balanced result. Now the company's delivery time data in minutes for 5 deliveries, 18, 22, 25, 19 and 21. The mean delivery time, found by adding all values and dividing by 5, is 21 minutes. The median, once the values are sorted, is also 21 minutes. The variance found from the mean of the squared deviations from the mean is 6. The standard deviation is the square root of 6, about 2.449 minutes. On any day, the probability a delivery is on time is 0.8. If a delivery is late, the probability of a complaint is 0.6. If a delivery is on time, the probability of a complaint is only 0.05. Using a tree diagram, combining both branches, the total probability of a complaint is 0.16. Let x be the number of complaints out of 3 deliveries, each with that 0.16 chance. Using expectation equals number of trials times probability, the expectation of x is 3 times 0.16, giving 0.48 complaints on average. Delivery times across the company are normally distributed with mean 21 minutes and standard deviation 2.449 minutes. Standardizing a delivery time of 25 minutes using z equals the quantity x minus the mean divided by the standard deviation gives a z-score of about 1.633. Reading this from the normal distribution gives a probability of about 0.949 that a delivery takes 25 minutes or less. This is shown as the raw curve centered at 21, then the same running caption updates to show the standardized curve centered at 0. Comparing distance traveled against delivery time for 5 deliveries shows a very strong positive pattern. The correlation coefficient is about 0.98. The regression line is approximately time equals 10.5 plus 3.2 times distance. Finally, the company claims its mean delivery time is 20 minutes. The null hypothesis is that the mean is 20 minutes, and the alternative hypothesis is that the mean is greater than 20 minutes. Using the sample of 5 deliveries, the test statistic works out to about 0.913. Comparing this against a critical value of about 2.132, the test statistic is smaller, so there is not enough evidence to reject the company's claim.